Hey everyone, and welcome back for another deep dive where we unpack some fascinating topics. And today we're going to be looking at something pretty exciting in the world of manufacturing.
Yeah.
We got our hands on a technical document all about this new tool called CERMILL. Pretty cool name, I gotta say.
It is.
And it's all about shaping these like really tough metals, the kind they use in like jet engines and power turbines,
Yeah.
So if you're the type of person who loves learning about the cutting edge of manufacturing tech, this deep dive is definitely for you.
I think so, yeah.
So is CERMILL basically like the next step in this?
It is, yeah. That's a great way to put it.
Okay.
CERMILL is specifically designed to handle some of the toughest materials out there. We're talking about things like nickel-based superalloys.
Oh, wow.
Yeah, that's what they use in jet engines because it can withstand such high heat.
Makes sense.
And also cast iron, which is used in everything from engines to like heavy machinery.
So it's kind of like a workhorse material in a way?
Absolutely, yeah. It's everywhere.
Okay, so we've got these really tough materials, and CERMILL is the tool to shape them. But what is it that really makes it different from, I don't know, any other end mill on the market?
Well, there are two main innovations that really set it apart.
Okay, what are we looking at?
First of all, it's got this unique clamping mechanism, which allows them to fit more teeth.
More teeth, okay.
Yeah, compared to other end mills of the same size.
More teeth?
More teeth means it can cut through metal faster and more efficiently.
So that's like a pretty big deal, right? Like that's one of the fundamental challenges in machining, how to remove more material quickly, but also keep that precision.
Exactly.
So what kind of gains are we talking? Like, are we talking minutes, hours?
It really depends on the application, but you could be looking at a 20 to 30% improvement, or even more in some cases. So yeah, it's significant.
That's huge. Okay, and what about that second innovation you mentioned?
The other big advantage is how easy it is to replace the inserts. Inserts, those are the cutting edges, the parts that actually do the cutting, and they wear down over time with CERMILL. You can swap those out incredibly quickly. You don't even have to remove the tool from the machine. So
that means less downtime, more productivity. That's got to be music to a manufacturer's ears.
Exactly. Time is money, right?
Yeah.
Every minute a machine is down, it's costing money. So that quick insert replacement really minimizes that downtime and increases productivity.
And when you combine that with the cutting efficiency we talked about, that's got to be pretty powerful.
It's a game changer.
Okay, so where would a tool like this actually be used? Like, what are some real-world examples?
Well, picture this, right?
Yeah.
You've got a jet engine with all those intricate parts, or a turbine blade with its complex curves, even the precision grooves in a car engine. Those are all areas where CERMILL could really shine.
Okay.
Because it's not just about handling tough materials. It's about the precision and the ability to create these really complex shapes.
So this is really pushing the boundaries, not just of what we can do, but like what we can even imagine, right?
It is. It's not just making things faster. It's opening up possibilities for new designs and manufacturing techniques.
So like what sizes does this thing even come in?
Right now they offer 16, 20, and 25 millimeter diameters.
Okay, so that's like a decent range.
Yeah, it covers a good range of applications. Plus, the end mill body itself has this special coating.
Oh, interesting.
It's designed to make the chips, the metal shavings, flow away easily, so that reduces friction and heat, which is important.
I could see that being a problem.
Yeah, it protects the tool from wear and tear.
Okay, so let's get back
Yeah.
to those ceramic inserts, because those are kind of the heart of this technology.
Right, they're the stars of the show.
Right.
They're single-sided and round, and they come in different grades.
Different grades.
Yeah, IS-14, IS-15, and IS-45.
So like, what's the difference?
They're each tailored for specific materials.
Okay.
So IS-14 and IS-15 are best for those superalloys we talked about earlier.
Right, the jet engine stuff.
Yeah. While IS-45 is more versatile,
Okay.
it can handle both superalloys and cast iron.
So it's like a multi-tool.
Exactly.
Okay, and I noticed a couple of important notes in the document. One was about using only dry coolant, so why not wet coolant?
Well, the ceramic inserts, they're really hard and wear resistant, but they can be sensitive to sudden temperature changes.
Oh.
Wet coolants, they're usually water-based, and they can cause what's called thermal shock.
Uh-oh.
Yeah, when they come into contact with the hot ceramic, that can lead to cracks or damage.
So it's better to be safe.
Right. Dry coolant uses compressed air, which removes the heat and chips. but without the risk of that thermal shock.
Okay, so it's finding that balance between cooling and also protecting the tool itself.
Exactly.
And there was also this note about tightening torque. What's the significance of that?
So torque, that's basically a twisting force. And when you install those inserts, you need to tighten them to a specific torque. In this case, it's 0.7 Newton meters.
Look.
That ensures they're held securely in place.
Makes sense.
And won't come loose during operation. They even have this optional tool that helps you apply the correct torque every time.
So it takes the guesswork out.
It does, yeah. Enhances precision and safety.
Okay, so to wrap it up, CERMILL really feels like a big step forward in machining.
Absolutely, it is. Innovative clamping, quick insert changes, those amazing ceramic inserts. It all comes together to make things more productive, more efficient.
And potentially even changing how we design things in the future, right?
Yeah, with advancements like this, who knows what will be possible to machine in the future.
Makes you wonder about other industries too. Like, where else could this tech lead to breakthroughs?
Yeah, the possibilities are pretty vast.
Definitely a lot to think about. Well, thanks for joining us on this deep dive into the world of advanced machining. If you're interested in learning more, be sure to check out the show notes for some links. Until next time.